at metrics. So linear algebra, metrics, I know we did a little bit of this in first year, but we'll go a bit deeper into this. Now, remember we said this is a 2 by 3 matrix because we have what? 2 rows and 3 columns. So, an example of a 2 by 3 matrix is what is represented in this example on this slide. Now, it is vital to note that in matrix, the row numbers always come before what? The column number. So, the row comes first and then the column. So, when you are also multiplying, like we said in first year, you multiply from the row and then down to the column. So, it's important that you note that rows are very, very important when dealing with metrics. Now, so all that has been discussed, the dimension of the vectors and all that. So you can see now that we have some matrices example. So this is just telling you the different kinds of metrics you could come across. Now this is a 3 by 3 matrix. Why? Because the row is what? 1, 2, 3, and then the column is 1, 2, 3. This is a 2 by 3 matrix because the row is just 1, 2, and the columns are what? 3. This is called 3 by 1 matrix because the rows in this column are 3 and then just 1 column. And then this is called 1 by 3 matrix, and then because we have 1 row and also 3 columns. So it's important that we understand that the rows in the matrix come first before the column. So if you are asked to identify what this matrix is, you should be able to say it's a 3 by 3 matrix by looking at it from rows and also looking at it from column. So if you look at this one, you see that the row comes first, which is 1 row, and then you have what? 3 columns. So that's that. So it's it's all this has been discussed. So you see, now there's what we call the transpose of a matrix. So the notation of transpose of a matrix in the case of matrix B is always written as B with an apostrophe, or it can be written as BT. Now when you see it like that, know that that particular matrix has been transposed. Now if you go back to our former matrix, this is matrix B, where we have 1, 2, 3, 5, 6, 7. Now, for you to transpose this matrix, it means you have to now rotate the algebras within the matrix. And when you do that, you have a resulting matrix, which now changes to a 3 by 2 matrix from a what? A 2 by 3 matrix. So it means that we are going to transpose this first row into column and transpose the second row into the second column to have that. So you see that 1, 2, 3 now becomes the first column, and 5, 6, 7 now becomes the second column. This matrix has been transposed. So that's what we call the transpose of a matrix. So you can have a matrix transposed, and the columns and rows will also change as a result of the transposition. So that's what happens to matrix in this course. So we have vector matrix, where we have 2 forms of vector matrix, the column vectors and the row vectors. So there are basically 2 forms of a vector matrix. So if you are asked in the exam, what are the 2 forms of vector matrix, you should be able to say column vectors and row vectors. So the former one in which is one in which the numbers are arranged literally, while the later is what? They are arranged in numbers in a matrix in a vertical order. So we have here that an n by 1 matrix, or an n by 1 column vector A, and a 1 by n row vector B yield a product matrix A and B in a dimension where we have n by n. For example, supposing that we have A matrix 5, 2, and then we have B 2, 4, 7. You find out that going by the principle of multiplication, we have the matrix A times matrix B. So we'll have what? A situation where we multiply 5 by 2 and then also multiply 2 by 4, get? And also multiply 2 by 6. So if you want to multiply, you say 5 times 2, then 5 times 4, then 5 times 6. And then you do the same for the lower row, 2 times 2, 2 times 4, and then 2 times 6. That will give you a new vector, a new matrix. And you see that the new matrix has been transformed into a 2 by 3 matrix form. So that's how we do for multiplicating matrix. So this one also, supposing we have this time around just 1 by 2 matrix from this. You know this one was 2 by 1 matrix. So now we have 1 by 2 matrix, and then we'll have, so we've interchanged it. So if you interchange it, you still get the same answer. We'll have 5 times 6 plus what? 5 times 9, which is equals to 48, and also 2 times 6 plus 2 times 9 will also give you the resulting answer, which is 48. So the slope of this resultant matrix is 1 by 1, as already indicated in the previous slide. So there are laws, various laws of metrics, which I'm not going to. You can read them, they are very simple, straightforward. So there's no point giving detailed explanation on them. So they are here, you can read about them and understand what it is. So if you look at the example, for instance, we'll have a situation where we'll have matrix A is equal to 11, 4, 3, 5, matrix B 8, 2, 1, 3. And then we say, show that the matrix addition and subtraction are commutative by maybe A plus B is equal to B plus A, and 2, A minus B is equals to A minus, sorry. So, hang on. So, yeah. So you see that we have this. So to calculate this, we just simply do the working. So we have A and B. So A plus B, 18 plus 11 plus 8, 4 plus 2. In the first row we have 19. In the second one we have B plus 8, where 8 minus 11 and 2 plus 6. So that will give you 16, 19, 6, 4, 8. That's this plus this 19, this plus this 6, this plus this 4, and this plus this 8. Then the second one we have A minus B. So it means 11 minus 8, 3, 4 minus 2, 2, 2 minus 1, 3 minus 1, 2, and then 5 minus 3, 2. So that's